Hello guys, so welcome to our new lecture of class 12 maths chapter 3, that is matrices, and this is of NCERT portion. Till now we have seen like many part of matrices, that what are matrices, definition of matrices, order of matrix. Then we have seen like topics, properties of matrix, and what is like your matrix addition, matrix multiplication, and also we have seen the properties of these like operations. Then we have also seen the like transpose of matrix, what is symmetric and skew symmetric matrices, and then we have seen the inverse of matrix and elementary operations also. We have seen in the previous class to find out any inverse of a matrix. So let's start this topic, and we will see some question of this, and how to find the inverse of any matrix using the elementary transformation. So I will explain you one or two questions, then you can do the other by yourself. So let's start with this. I will take the second question. So how to do this? Write the matrix as A is equal to IB. Okay, like this only. You can write like this. So here A matrix is what? 2, 1, 1. And it can be written like what? Identity matrix, that is 1, 0, 1, 0, 1, and 1. Sorry, just a second. Yes. So this is your like written like what? 1, 1, 0, 0. Okay. And it is your like here is your B matrix. Okay. So this is the like process to find out the any your inverse of a matrix. Okay. Here we have already talked about this in the previous class, that how to find the inverse of a matrix. So we have written it like what? A is equal to IA. So A is here written like this, and then IA. Okay. That is how I have written here also, using the this is the row operation like that we have done here. Okay. So let's do the this question. Okay. So A is equal to IA can be written like this only. So yeah, here you can write it like what? A equal to IA. So this is your A here. Okay. Now do some row operations on the left hand side, similarly for right hand side. So here just to try to make zero more zero here, and make it equal to I matrix, that is identity matrix. Okay. So I will do what? Yes. I will do row 1, we change to row 1 minus row 2. So what you will get? 1, 0, 1, 1. Okay. The left hand side and on the right hand side, what you will get? 1 minus 1 and 0, 1. And it is A. And now you have to make it another 0 here, like this one. So you will do what? Row 2 is equal to row 2 minus row 1. What you will get? 1, 0. Here 1 minus 1 you will get as 0. And here you will get as 1. Okay. And here what you will get? Row 2 minus row 1. So 1 minus 1, and here minus 1, and here you will get 2. Okay. So this is your identity matrix in the left hand side. See here. So A will be what? Like your A inverse will be equal to 1 minus 1 minus 1 and 2. Okay. So this is your inverse matrix for the given matrix 2, 1, 1, 1. You can verify it by multiplying to the original matrix and you will get identity matrix holder. So that is how you can solve this question. Now I will explain you another example of a like this matrix. And yeah, let's clear all the drawing. Now I will take one more question of this exercise. Let's solve 15th one. Okay, then I believe that you can solve the other parts of this because all are similar only, and we want to apply the row transformation or column transformation. Many times we do the row transformation because that is easier and easy to remember also and apply also. Okay, let's do the 15th question. So I can write it like what? I into A. So yeah, it can be written like 1, 1, 1, 0, 0, okay, 0, 0, and 0, 0 into A. Now, what you will do first, try to make more zeros here. So I will do one thing that row 2 is equal to row 2 minus row 1. Do this, what you will get? Row 2 minus row 1. So you will get as 2 minus 3, 3, then here 0, 2 minus 3 minus of minus 3, that is 5. 3 minus 3, you will get 0 here. Okay. And then here 3 minus 2, then 2 only. And in this side, you will get 1, 0, 0. This row minus this one. So minus 1, 1, 0, 0, 0, 1, and A here. Okay. This is first transformation. You are getting 2 zeros here. See, I am trying to make this more zero here. Now what you will do next step? In the next step, you can do that. Just take the difference of what? Row 3 is equal to and row 3 is equal to row 3 changes to row 3 minus of row 3 plus row 1. Okay. So what you will get? 2 minus 3, 3, 0, 5, 0, and minus row 3 means minus 3 plus row 1. So you will get what? Minus 1. Minus of this plus this means what you will get here? 1, and here minus of this plus this 1. Okay. So this here you are getting on the left hand side. The right hand side you will get 1, 0, 0, minus 1, 1, 0, and here 1, 0, minus 1 times A. Now what you can do in the next step, that row 1 can be changed into what? Row 1 plus row 3. Okay, what you will get then? Here you will get 1. Here what you will get? Minus 2, 4, 0, 5, 0, minus 1, 1, 1. Okay. On the right hand side, you will get as 1, and this is 2, 0, and then minus 1. And here minus 1, 1, 0, and 1, 0, minus 1 into A. Okay. Now I should clear some steps so you can write it here also. I will remove this. Okay. So you can write in the above lines also. Yes. So I'm getting like this only. Now I will make row 2 is equal to row 2 by 5. So row 2 is changing into row 2 by 5. What you will get 1 minus 2, 4, 0, 1, 0. And here minus 1, 1 and 1. Okay. Here you will get 2, 0, minus 1, minus 1 by 5, 1 by 5, 0. And here that is 1, 0, minus 1, 1, 0, minus 1. Okay. Into A. Now, what you can do in the next step that row 3 minus row 3 change to row 3 minus row 2. So you will get 1 minus 2, 4, 0, 1, 0, minus 1, 0, 1. Okay. And here you will get what? 2, 0, 1, minus 1, minus 1 by 5, 1 by 5, 0. And here 6 by 5, minus 1 by 5, minus 1 into A. Okay. The next step, you can do one thing that row 1 changes to row 1 plus 2 times row 2. Okay. So you will get like 1, 0, 4, 0, 1, 0, minus 1, 0, 1. And here you will get as row 1 is row 1 plus 2 times row 2. So what you will get? 2 minus of 2 by 5. Okay. So 8 by 5. 8 by 5. Then here we will get what? 2 by 5. And here 1 minus 1 only. And here minus 1 by 5, 1 by 5, 0, 6 by 5, minus 1 by 5, minus 1. Okay. So you are getting like this only. Now, what you can do in the next step that, yes, row 3 changes to row 3 plus row 1. Okay. So what you will do here? 1, 0, 4, 0, 1, 0. And row 3 plus row 1, you will get what? 0, 0, 5. And here 8 by 5, 2 by 5, minus 1, minus 1 by 5, 1 by 5, 0. And in the next row, you will get what? So here you will get as 14 by 5, 1 by 5, and minus 2 into A. So I am getting like this only here. Now there are like 2 and 1 or 2 steps more, then you will get the answer. Okay. So, yeah. Now, what you can do in the next step, that take the your row 3 as row 3 by 5. Row 3 as row 3 by 5. So you will get as 104 010 001, and here you will get as 8 by 5 2 by 5 minus 1, and here it is like what it is here, minus 1 by 5 1 by 5 0, and here it is minus 14 by 25, because it is 1 by 5 both the sides. Okay, and 1 by 25, and here minus 2 by 5. Now in the next step, what you can do, that just row 1 changes to row 1 minus 4 times row 3. You will get the final answer. So just do this, you will get what? 1 0 0. Okay, and here 0 1 0, and here 0 0 1. Here you will get identity element here in the left hand side, and here you will get as your row, like yes, and row 1 is turned into row 1 minus 4 times row 3. So what you will get here, 8 by 5 minus or plus sign here, 4 into 14 by 25. So here you will get what? This is 56 by 25 plus 8 by 5. You will get 25 in the denominator, and here you will get as, yeah, 96. So in the upper side, you will get 96 by 25, then 2 by 5 minus of 4 by 25. Okay, so here you will get what? 6 by 25. 96 by 25, 6 by 25, and here minus 1 plus 8 by 5, that is equal to 3 by 5. So here you will get 3 by 5 as a 3 by 5, and rest are same, that is minus 1 by 5, 1 by 5 0, and here minus 14 by 25, 1 by 25, and minus 2 by 5. So this is your final answer. This is your like inverse of this matrix. So it was a lengthy question, but when you try it, you can solve it by taking many steps. Okay, so that is how you can solve the like 3 cross 3 matrix also. So I hope you got this point, that how I have done these operations here. So let's move to the next thing and next question, and let's find out that what is this in the next part. Okay. So matrices A and B will be inverse of each other only if AB is equal to BA, AB is equal to BA is equal to 0, AB is equal to 0, BA is equal to I, AB is equal to B is equal to I. So this is the final correct option, that D option should be correct here. AB is equal to B is equal to I. Which is the your like genuine condition for AB and B to be inverse of each other, that we have already studied in the previous class. You can check out the video on the official website or like YouTube channel of GoAskNow technology. Okay, let's move further. Now some miscellaneous examples are there. So we will see that how it is solved. Like we will take one or two examples. So let's do this also. In the example 76, it is saying that if A is equal to cos theta sin theta minus sin theta cos theta, then prove that A to the power n is equal to cos n theta sin n theta minus sin n theta and cos n theta for n belonging to natural number. We shall prove that this result by using principle of mathematical induction. Okay, so it can be proved by mathematical induction. So if we have like if En is equal to if A is equal to cos theta sin theta minus sin theta cos theta, then An is equal to what? Cos n theta sin n theta minus sin n theta cos n theta for n belonging to natural number. So P1, that is for n is equal to 1, the A will be equal to what? Cos theta sin theta minus sin theta cos theta. So K1 will be equal to only convert to that cos theta sin theta minus sin theta and cos theta. Therefore, the result is true for n equal to 1. Yeah, this is true because the result is coming out to be same. Let the result be true for n equal to k. So we will assume that this result is true for n equal to k. So pk is equal to what? A is equal to cos theta sin theta minus sin theta cos theta. Then ak will be equal to for any n is equal to k. Ak will be equal to what? Cos k theta sin k theta minus sin k theta and cos k theta. Okay. Now we will prove that the result holds for n is equal to k plus 1. So if it is true for k, then it should be true for k plus 1. If it has to be like it has to be if it has to be true for all natural number. Okay. So ak plus 1 is equal to what? A into ak. You can write ak plus 1 as a into ak. So it can be written as cos theta sin theta minus sin theta cos theta into cos k theta sin k theta into sin k theta cos k theta. Now take the product of these two matrices. You will get as cos theta cos k theta minus sin k theta cos theta sin k theta plus sin theta cos k theta. The minus sin theta cos k theta plus cos theta sin k theta and minus sin theta cos sin k theta plus cos theta cos k theta. Okay. Now you can see here that this is the formula of what? Cos A plus B. So you can write it like what? Cos theta plus K theta. Okay, cos A plus B formula is this. That is cos A cos B minus sin A sin B. Okay. Similarly, for the second element, you can see that it is the formula of sin theta plus K theta. This is a compound of the formula for sin A plus B. Similarly, for the third element, you can observe there and this is minus of sin theta plus k theta formula. Okay. And in the same way, cos theta plus k theta is the final element of this matrix. So it can be expressed in the terms of what? Cos k plus 1 theta. Okay. And the second term is sin k plus 1 into theta. Third element is minus sin k plus 1 theta. And fourth one is cos k plus 1 theta. So I hope you got it that how we have written this. And you can observe that this is the result for your n is equal to k plus 1. Because here k is replaced by k plus 1 only. That we have already wanted to prove this. We wanted to prove that it is true for k plus 1. K plus 1 theta. Okay, k plus 1 element. So yeah. So this is proved that this is true for k plus 1 by principle of mathematical induction. So I hope that you got this question that how it is solved. First, we have proved it for any here, like for one n is equal to 1, then for k n is equal to k, then we have to prove it for n equal to k plus 1 also. So that will prove our like this question that it is true for all natural numbers. Okay. So yeah, let's move forward and see what is the next question. If A and B are symmetric matrices of the same order, then show that AB is symmetric if and only if A and B commute. That is AB is equal to BA. Okay. So here it is given that A and B are symmetric matrices of the same order. And we have to show that AB is symmetric if and only if A and B commute. It means that AB should be equal to BA. Since A and B are both symmetric matrices, therefore A dash will be equal to what? A and B dash equal to B. Let AB be symmetric. So we assume that AB be symmetric. Then AB whole dash equal to what? AB. Because if any like matrix is symmetric, then its transpose is equal to that matrix only. So AB dash is equal to AB. Okay. Now AB whole dash is equal to B dash A dash also. Because AB dash can be written as B dash A dash. That is the property we have earlier seen in the transpose of matrices. So it is equal to BA. Why? Because B dash is equal to B and A dash equal to A only. So BA equal to AB is coming from the both the conditions. Conversely, if AB is equal to BA, then we shall show that AB is symmetric. Okay. So we can show it like in converse way also. Now AB dash equal to B dash A dash. Okay. That is equal to BA and B are symmetric. That is equal to AB, hence AB is symmetric. So that we have proved in the other view also. So that is here proved that if they are congruent, they so the AB is symmetric, or if AB is symmetric, then they will congruent. I hope you got this question also. Let's see the next question. So example 28 says that let A is equal to 2 minus 1, 3, 4. Okay. And B is equal to 5, 2, 7, 4. C is equal to 2, 5, 3, 8. Then we have to see what? That find a matrix D such that CD minus AB is equal to null matrix. Then say B, C are all square matrices of order 2, and CD minus AB is well defined. D must be a square matrix of order 2. Okay, because C is multiplied with D and it is taken difference with AB. So CD minus AB should be equal to like D has also the order should be equal to 2. So let D is equal to A, B, C, D. When CD minus AB is equal to 0 or null leaves us 2, 5, 3, 8 into A, B, C, D minus 2 minus 1, 3, 4 into 5, 2, 7, 4 equal to 0. Now compare both the sides after like doing this matrix multiplication and both the sides matrix multiplication and then taking the difference, just equate the left hand side elements to right hand side 0, 0, 0. You will get 2a plus 5c minus 3 is equal to 0. Then 3a plus 8c minus 43 is equal to 0. 2b plus 5d is equal to 0. And 3b plus 8d minus 22 equal to 0. You are getting variables in log linear equation in two variables, and that are of two types. One is A and C type, and second is to B and D type. Okay. Solving first and second, we will get that A is equal to minus 191, B is equal to 77, and solving 3 and 4, we get B is equal to minus 110 and D is equal to 44. So your therefore your D matrix is minus 191, minus 110, 77, and 44. So yeah, I hope that you got this question. So let's move forward and see what are the miscellaneous exercise on this chapter. So here are some questions in this exercise also. So I hope that you can solve the first and second, because this is like the single question I stand in the example of miscellaneous exercises that is done by principle of mathematical induction. So you can do this by that only. Okay. Similarly, you can do the third one also. And the fourth one we have just talked about, that is also similar to that. Okay. So these all questions are easy if you try to do this. And if you find any difficulty, you can comment in the chat box. We will answer that question. And I hope that you understood whatever I told you today. And anything you have any doubt with us, you can comment. Okay. So yeah, these are the questions. Like, these are not very important for your board level, but if you want to practice, you can do these questions. Okay. Now this is the summary of this chapter. You can learn it by yourself. The whole thing is like given in this summary. Whatever I told you in this chapter, whatever I like taught you in this chapter, this is given whole summary of that. So the next chapter determines, we will take it in the next lecture, because we could start the next chapter with a fresh lecture. So till now, if you have any type of doubt or any type of concern, you can tell us in the chat box. Also, if you want any kind of one-to-one session or private session from us, you can also tell us in the chat box. So I hope that you liked the today's lecture. And if you have any kind of difficulty in learning, or if you have any kind of queries for this lecture, you can comment in the chat box also. So yeah, let's end this chapter and end this lecture right now. Thank you and have a great day.